Tucked away in Utah's Uinta Basin sits a 512-acre property known as Skinwalker Ranch. For decades, this specific patch of desert has been reported as a geographic hotspot for anomalous phenomena. The property's early reputation was built on strange, unsettling folklore. Locals and former owners described cattle vanishing without a trace, unidentified flying objects, and invisible destructive magnetic fields sweeping across the land. In 1996, real estate mogul Robert Evelo bought the ranch and launched the National Institute for Discovery Science to investigate these claims. But his team ran into a massive roadblock. While they tried to apply standard scientific approaches, they were ultimately forced to rely on subjective eyewitness anecdotes rather than hard, measurable data. Mainstream scientists were quick to criticize this methodology. Renowned skeptic James Randi publicly mocked Bigelow's efforts, awarding him the satirical Pegasus Award for funding what he considered a useless study of the supernatural. This highlights a critical dilemma in anomalous research. Without a continuous stream of verifiable quantitative data, you cannot prove an event is a genuine physical anomaly, and you cannot prove it is a hoax either. Human memory is simply too flawed to serve as a reliable baseline. Resolving the mystery of Skinwalker Ranch required a departure from the traditional investigative model. If the goal was hard evidence, researchers needed to move past human observation and find a way to let the data speak for itself. That transition began when investigators partnered with LiveView Technologies. LVT was brought in to deploy an enterprise-grade, cloud-based video surveillance security network designed to monitor the entire property 24/7. By dropping multiple autonomous camera nodes across the 512-acre grid, the team eliminated the blind spots of reactive observation. They replaced the practice of chasing anomalies with a continuous, empirical dragnet. This network of sensors effectively transforms the physical ranch into a living laboratory. Every square inch can be cross-referenced and analyzed in real time. But installing enterprise-grade hardware only solves half the equation. Gathering terabytes of raw environmental data is useless if you don't have a highly trained mind capable of interpreting the complex physics behind it. Enter Dr. Travis S. Taylor, the chief scientist tasked with deciphering the incoming sensor data. Taylor brings a 25-year resume grounded in hard physics. With PhDs in aerospace systems and optical science, he spent decades developing advanced propulsion and laser systems for NASA and the Department of Defense. From 2020 to 2022, his work moved into highly classified territory when he served as the chief scientist for the Pentagon's Unidentified Aerial Phenomena Task Force, evaluating military sensor data on unexplained objects. At Skinwalker Ranch, Taylor applies this exact same methodology. He does not look for the paranormal. Instead, he uses the rigid framework of aerospace systems engineering to search for measurable causal mechanisms. By deploying ground-penetrating radar and electromagnetic sensors, he looks for empirical profiles that break established aerodynamic rules, like physical objects capable of instantaneous acceleration without generating a thermal signature. Taylor's involvement bridges a massive historical gap. He applies the highly classified analytical rigor of military threat assessment directly to a public, open-air anomalous investigation. This crossover has generated significant friction. Mainstream scientists have heavily scrutinized Taylor's deployment to the ranch. Institutions like the SETI Institute have publicly questioned his credibility, arguing that associating with a reality television production and historical supernatural claims is incompatible with serious analytical research. Taylor's defense is rooted in the core principles of his training. He argues that true scientific empiricism requires testing hypotheses against physical laws, no matter how uncomfortable or bizarre the resulting data might appear. If a calibrated instrument records a massive spike in electromagnetic radiation, or a radar array tracks an object defying inertia, ignoring that verifiable sensor data simply because it challenges conventional physics is exactly the opposite of the scientific method. Today, campfire folklore and unreliable eyewitness accounts are being replaced by multi-sensor data fusion and optical physics. Investigators now prioritize enterprise-grade surveillance over the fuzzy photographs that characterized earlier decades. Whether the Uinta Basin plays host to adversarial drones, natural weather events, or something else entirely, The investigation now rests on a baseline of telemetry. The hunt for the unknown is becoming an exercise in data management.